Hey everyone, today we are diving into alkanes as part of our organic chemistry series. So let's get started. So alkanes belong to the homologous series saturated hydrocarbons. Remember saturated, remember homologous series, they always contain the same functional group. So here in the alkanes, the functional group is carbon-carbon single bond. They have the same general formula, CnH2n plus 2 in the case of alkanes, and then the members that differ from one to the next by a CH2 unit. So the simplest alkane is a methane with a single carbon, and when you add another CH2 to the methane, the first member of the alkane hydrocarbons, it becomes ethane. So remember the members that differ from one to the next by a CH2 unit. There is a consistent trend in the physical properties with increasing molecular size. Here we go. So if you see the physical properties, there is a trend. There is a trend in the physical properties. So if you look at this picture, here you can see that as the number of carbon atoms increase, what is happening? The boiling point also increases. So under normal conditions, the first four, carbon 1, carbon 2, carbon 3, carbon 4, the first four members of the straight chain alkanes, they are gases. I hope you all are able to infer this graph. So here at the y-axis, we have the temperature and the number of carbons on the x-axis. And if you see, the first four are gases. So as the number of carbons increase, you see that they change the state to a liquid. So here, if you see the alkanes between carbon 5, okay, and carbon 16, they are all liquids. They are all liquids. The compounds in the alkane family with 17 or more carbons, 17 or more carbon atoms are solids. So there is a trend, the trend in physical properties with increasing molecular size. Now, why does this happen? So the larger the molecule, the higher the boiling point. Remember the trend, the larger the molecule, the higher the boiling point. This is because the large molecules are attracted to each other. See, they are all here. If the molecule is really large, they are attracted to each other by more strongly. They are attracted to each other more strongly than smaller ones. So if you compare, a molecule which has only 2 carbons, they are a little weaker when compared to the larger molecules. So more energy is required to break these stronger intermolecular forces of attraction. So this increases the boiling point. This increases the boiling point. Okay, so more energy is needed to break these stronger intermolecular forces of attraction to produce the widely separated molecules in a gas. So hope you understand that the physical properties, so there are lots of physical properties. Here we are talking about boiling points. There could be viscosity, there could be volatility. Okay, so also the colors can also be different. So we will not go in detail about the physical properties here, except for that the boiling points, the larger the molecule, the higher the boiling point. So the trend, you look at the trend. Remember, compounds belonging to the same homologous series have the same kind of chemical properties. So let's look into the chemical properties of alkanes. Okay. Now, the first thing we will talk about is combustion of alkanes. So alkanes burn readily. Okay. When they burn in a good supply of air, that is when there is a lot of oxygen, when there is no limit or lack of oxygen, when they burn in a good supply of air, the products are carbon dioxide and water. So whatever be the alkane, whether it is a methane, ethane, butane, whatever be the alkane here, whichever saturated hydrocarbon you take, if they burn in a good supply of oxygen, they will always give the product as carbon dioxide and water. So this is called combustion. This is called combustion. So burning in excess of oxygen is called combustion. And any alkane which burns in excess of oxygen will produce carbon dioxide and water. So remember, the same products are obtained whichever alkane is burned, so long there is sufficient oxygen that is there, a sufficient oxygen supply. And one more thing that you need to note is the key to balancing these equations. So how are you going to correctly balance the equations is to see the oxygen correctly. So if you're going to balance the oxygens correctly, then you can easily get the equation right. Okay. So when there is sufficient supply of oxygen, you get carbon dioxide and water. However, if the air supply is limited, if the air supply is limited, it is called incomplete combustion. So when there is excess of oxygen, it's called combustion. If there is a limit in the supply of oxygen, then it is incomplete combustion. Then the poisonous gas carbon monoxide is produced. Okay, carbon monoxide is a product of incomplete combustion of the hydrocarbon. Now, this is a very poisonous gas. This is a very, very poisonous gas. It can produce fine particles of carbon, that is soot. I'm sure you must have heard this word soot, that black soot that is formed. These particles of carbon have not even reacted to produce carbon monoxide. It is these fine carbon particles that glow, that can glow yellow in the heat of a flame. They give a candle flame or the safety flame of a Bunsen burner its characteristic yellow color. So incomplete combustion of fossil fuel is a major cause of air pollution. Remember this. So this happens to all alkanes. Okay. So the next reaction that alkanes take part is called the substitution reaction. So in this reaction, usually they, take part, they have the substitution reaction with the halogens. That is the group 7 elements. So the halogens. Okay. Now here we will see how the alkanes, when they react with chlorine, what do they form? So in these reactions, a hydrogen atom is replaced by a chlorine atom. So hydrogen is replaced by a chlorine. A substituted chloroalkane is produced altogether. So here you can see that a chloroalkane is produced together with hydrogen chloride gas. The hydrogen chloride gas can be detected using moist blue litmus paper, which turns red. Hope you are noting down the equations. because they are important. And remember that alkanes, they are very unreactive compounds. Alkanes, they do not take part in addition reactions. They can take part in substitution reactions, particularly with chlorine. Particularly with chlorine. And what is a substitution reaction? It's a reaction in which an atom is replaced. If you see here, C2H6. So one of the hydrogens is replaced by a chlorine. So a reaction in which an atom of a molecule is replaced by a different atom without changing the molecule's general structure. So alkanes take part in substitution reaction where one atom of a molecule, here the hydrogen, is replaced by a different atom without changing the molecule structure. And thus we have chloromethane, chloroethane, or whatever the alkane is, it is produced. So chloroalkane is produced. So let me write the general term here. So it's chloroalkane, which is produced along with hydrochloric acid. Okay, now there is a condition involved in this reaction. And what's that condition? You need to have UV light. So this is the condition. So because the substitution reaction of an alkane with chlorine, it requires, for the activation energy, it requires light, that is UV light. It is called a photochemical reaction. It's called a photochemical reaction. Remember, I hope it's not confusing. There are conditions for reactions to start off. First of all, you need some activation energy for a reaction to start off. So that activation energy is UV light. Okay. So methane and chlorine. Now, if you see methane and chlorine, they react in the presence of sunlight or a source of UV light. It's a source of UV light. Let me take this off so that it's clear enough for you. Okay, there is no reaction between alkane and chlorine in the dark. Remember, when it is dark, this reaction will not happen. So when it is dark, this reaction will not occur. Only when there is this condition fulfilled, that is, it has UV light, chlorine and methane will react, and that UV light acts as an activation energy. Can I write EA for activation energy? So this is the activation energy which splits the chlorine molecules into separate energized atoms. So chlorine will get split into two atoms, and these atoms then react with methane. So the overall result is that a chlorine atom replaces a hydrogen atom in the methane molecule to give chloromethane. Okay, hope this is understood. Hope you have understood this. So the reaction can continue further as more hydrogen atoms are substituted. So compounds such as dichloromethane, trichloromethane, tetrachloromethane, all these can be formed. If the reaction continues in the presence of UV light, you can have CH2Cl2. So this is dichloro. Remember, di means two. So let me write that down. Dichloromethane. Dichloromethane or trichloromethane. CHCl3. So this is trichloromethane. And so on. It goes on this way. So all the other alkanes will react in a similar way. Remember, the chemical properties will be the same for all the hydrocarbons that are in the same homologous series. So here in this case, alkanes, all the alkanes will react in a similar way. They will react in a similar way. So if it is going to be butane, so if it is going to be ethane, it will make chloroethane. Shall we do it? Okay, we'll do it now. We'll write the reaction so that it is even more clearer. So if it is going to be ethane, when it reacts with the chlorine, what will it give? What will it give? It will give chloroethane. Chloroethane plus hydrogen chloride. Plus hydrogen chloride. Okay, try writing the chemical formula. Try writing pause the video here and write the chemical formula. So once you've done it, check with me. So C2H6, that's gas. When it reacts with chlorine, which is also a gas, what do you get? You will get C2H5Cl. See, one H is gone. One H is gone, and it reacts with the other chlorine atom to give you HCl. So here this is also gas and HCl is also gas. So the same thing will happen with butane, propane, whichever alkane it reacts with, it is going to give the same product. So ethane forms one monosubstituted product here. Longer alkanes can form more products. So because it is ethane, it is a short chain, short alkane. So it's kind of forming, just this with one chlorine atom. But if it is a longer chain, it can form more and more chlorine with chlorine atom. Okay. Now let's get back to the next reaction, which is called cracking. This is called cracking. So from the name, what do you understand? What is cracking? Cracking, it's a process, cracking, like breaking, right? So it's a process in which long chain alkanes are converted into alkenes. It's converted into alkenes and alkanes. So there can be other reactions where it kind of gives out hydrogen gas. So remember, a big hydrocarbon, here in this case C8H18, a big hydrocarbon molecule is kind of useless. We can't kind of use them longer than this. So we have to break them into smaller ones. Only then they become useful fuel. So big hydrocarbon molecules and fuel oil, for example, can be broken down into smaller ones, which are needed for petrol. So this is one simple equation. But here too, there are conditions applicable. What are the conditions? You need a catalyst. You need a catalyst, aluminum oxide. And look at the temperature. Temperature has to be between 600 and 700 degrees centigrades. So these are the conditions involved. So likewise, it either breaks into an alkene and an alkane or alkene and hydrogen. Whatever it be, if you add the number of carbons in the product side, it will be equivalent to the reactant number. Now let's test our knowledge of alkanes with a quick quiz with flashcards. Remember to pause the video after you see the question, write your answer, then check your answer. So what is a hydrocarbon? Pause your video here, write the answer down, and then check your answer. So hydrocarbon is a compound made up of hydrogen and carbon only. Name 3 fossil fuels: coal, natural gas, and petroleum. So is it true or false? The main constituent of natural gas is propane. Now think, is it true or false? It is false, because the main constituent of natural gas is methane. What does saturated mean? Pause. Write the answer down. Saturated means the compounds only have single carbon-carbon bonds with no double bonds. Alkanes are reactive compounds. Is it true or false? So the answer is false. And alkanes are generally unreactive compounds. That's why they don't take part in addition reactions. Instead, they take part in substitution reactions. Name the alkane that is predominantly present in natural gas. The alkane that is present in natural gas is methane. It is methane. What type of reaction occurs between alkanes and halogens? Think and answer. Alkanes undergo substitution reactions with halogens in the presence of ultraviolet radiation. Remember, the condition required for a substitution reaction is UV radiation. State the equation for methane reacting with bromine in the presence of UV light. So now again, pause, think, methane with bromine, and then the substitution happens, and what is the product? So here you go, methane, bromine, it becomes bromomethane. Bromomethane plus HBr is released, hydrogen bromide. State the equation for methane reacting with chlorine in the presence of UV light. So we saw this equation as methane plus chlorine gives you chloromethane plus hydrogen chloride. What condition is required for alkanes to react with halogens? It's ultraviolet radiation or UV light. Is it true or false? The products of complete combustion of an alkane are carbon monoxide and water. No. This is false. The products of complete combustion of alkane is carbon dioxide and water. And remember, all alkanes will give the same product, carbon dioxide and water, when the supply of oxygen is sufficient enough. So what is it, true or false? Ultraviolet light provides the activation energy for the photochemical reaction of an alkane with a halogen. So this reaction is also called photochemical reaction. Otherwise, it's a substitution reaction. Yes, true. Ultraviolet light provides the activation energy for the photochemical reaction of an alkane with a halogen. So draw a haloalkane produced by methane reacting with chlorine in the presence of UV light. So this is the haloalkane. Remember, this photochemical reaction is also the substitution reaction where one hydrogen is replaced with a chlorine atom. Okay, draw the haloalkane. Okay, this we finished. Now the next question. State the three reactions that alkanes can undergo. So what are the three reactions that alkanes can undergo? It's combustion. Combustion when there is sufficient supply of oxygen. It is incomplete combustion when there is a lack of oxygen. Cracking. So for combustion, it is either the presence of oxygen, cracking, you need a catalyst, and you also need the temperature to be between 600 to 700 degrees centigrade. There is substitution reaction with halogens where the condition is UV light. Okay, write the balanced equation for the combustion of methane. The balanced equation for combustion of methane is CH4 with oxygen gives you carbon dioxide and water. So these are the products which you're going to get for any alkane which undergoes combustion. What is the characteristic feature? Okay, now we will stop here